Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, it's a job high on the bucket list for maintenance supervisor Andy Schooler, managing a busy 4-day shutdown.
When you get moving parts, things wear out.
50 men versus 5 stories of a mighty preparation plant. But when the wind picks up, so does the danger.
You just know something's not looking right, so you just got to make the call.
There's nothing idle about this job. Hurdling 3 kilometres over conveyors at Port Waratah Coal Services, mechanical fitter Troy Bennis feels the burn.
I used to think it was a bit of a hero status to stay on there for too long.
But one misstep could bring this mighty machine to a standstill.
They've got the potential to cut or damage the conveyor belt.
A sticky situation at the Rocky Point Sugar Mill calls for a quick fix from hydraulic specialist Alan Osborne.
It doesn't fit, we have to make it fit. There's no choice, it will fit.
But will his sugar-coated solution get the mill back online?
Obviously keen to get going as soon as we can.
When it comes to burning rubber, these metallic birds take it to a whole new level. Making sure these flying kangaroos have plenty of spring in their step on landing is what this team specialise in. Senior laney Charles Lacina is keeping an eye on the team's progress.
It takes approximately half the weight of the aircraft landing forces.
Mining coal is a tough business, and the equipment even tougher. But without regular maintenance, it will break down. 130 kilometres west of Brisbane is the New Ackland coal mine near Oakey in regional Queensland. A 6 a.m. pre-start meeting in the maintenance workshop draws together a crew of 50 mechanical fitters and boilermakers for a marathon 96-hour shutdown. Their mission, the annual overhaul of Coal Handling and Preparation Plant number 1. The biggest job over the shutdown is the replacement of the jig elevator buckets. Spanning 3 stories, this revolving conveyor removes waste rock from the crushed coal. After 12 months of continuous operation, the buckets are due for replacement. And the only way to remove them from the preparation plant is up, lifting them 5 stories high through an open cutout in the roof.
Got some fairly major jobs happening, as we do on these extended shutdowns. Feeder breaker, rebuild, jig elevator bucket rebuilds.
Maintenance Improvement Coordinator Andy Schooler is in charge of this 4-day shutdown. Taking the preparation plant offline means no coal production, and with the demand for high-quality coal in hungry overseas markets, a 4-day shutdown of operations will run into millions of dollars of lost revenue. Some jobs will take just a few hours. But the replacement of the jig elevator buckets is a critical task and will take 8 shifts working around the clock for 96 hours.
You've got the biggest work group of people working on that job, and they have to all work together to make sure that that job comes in on time.
It's a huge operation, and with the clock ticking, safety checks take up valuable time, but they're not negotiable.
These fellas, before they do a job, they'll do what we call a risk assessment, or a JHA, a job hazard analysis. They go through and list step by step the parts of the job that they're doing, and they identify any hazards that are there.
Righto, work order matches, righto, sign away, thanks. There you go.
And with a plan of attack in place, it's time to pick up tools and take on this enormous project. To remove the jig elevator buckets from deep inside the preparation plant, Andy's called in a super-sized machine with a mighty reach.
So with the jig elevator lift, we bring in a 100-ton crane and they lift the jig elevators out. Not so much because the elevators are heavy weight, but because we're lifting them so high and at a full reach of the crane.
Extending the boom to 50 metres, the towering crane will thread its lifting hook and chains through these open cutouts in the preparation plant roof, raising the jig elevator buckets over 5 stories high, then ease them down to ground level. There's already been a casualty on a previous bucket lift, and crane rigger Russell Whitby can see a damaging reminder.
Looks like someone's hit the roof. So hopefully that's not us today.
But keeping this job on time will also depend on the weather, and a forecast of wind and rain could bring everything to a standstill. From outback Queensland to the seaside city of Newcastle, Port Waratah Coal Services is the largest coal export facility in the world, just 200 kilometres north of the state capital, Sydney, covering an area the size of 128 football fields. These mega machines and the expert mechanics who maintain them are a key part of the Hunter Valley coal chain, a 450 kilometre heavy haulage rail network from coal mines across the Hunter region to the Port of Newcastle. Working in the heavy maintenance industry for 32 years, Superintendent of Maintenance Ross Van Dyke has the responsibility of maintaining the facility's operations 24/7.
A large breakdown can have effect on the whole Hunter Valley coal chain. Potentially a conveyor breakdown might be a week's worth of work. So we put a lot of effort into eliminating those breakdowns.
Every year, the stockyards at Kooragang Terminal have the capacity to export 120 million tonnes of thermal and coking coal to destinations around the world.
We don't actually produce anything here. We don't make anything. We don't manufacture anything. We purely handle coal for our customers. And that's unloading, stacking, reclaiming, and then loading at ships.
65 kilometres of conveyors snake their way across the site, moving up to 65,000 tonnes of coal every hour. That's a heavy workload for tens of thousands of moving parts. Regular maintenance is done during shutdown periods, and today the task of replacing damaged idlers belongs to Troy Bennis and his crew. Troy has been a mechanical fitter at Port Waratah for 9 years, working on these massive machines towering 14 stories high.
Behind me is one of our 6 stackers that we have on site. This is 321 stacking machine. The maintenance team's been called out today to do an idler purge.
An idler is a rolling component used to support a conveyor belt. At Kooragang Coal Terminal, there are thousands of idlers operating around the clock. Idlers fail from excessive shell wear or seize from dust and grease damaging bearings.
And we'll go along the whole 3 kilometres of conveyor and check every idler and change out the damaged ones.
Working below the stacker from an idler changing platform, the crew need to be on their toes, hurdling over steel frames, spinning idlers for worn bearings, and looking for damage or wear.
The idlers are located every few metres. That's where the conveyor belt rolls over to make it nice and smooth without the coal falling in between. They've got an aluminium shell, so they're not too heavy, probably 8 to 10 kilos. Got a shaft in the middle with a slot that gets located in the roller frame, and it's got a bearing either end.
Missing one damaged idler could mean disaster.
Well, it could cut the conveyor belt, tear the belt up, which means big downtime and possibly repairs and replacing the belt. So,
shutting down operations on Stacker 321 for up to a week. Each hour the machine is shut down, that's a holdup of 8,500 tonnes of coal that can't be stockpiled along this row. From Newcastle to the sugar fields of Yatala, halfway between Brisbane and the Gold Coast. Contract cane harvesters are racing daylight to get the last of the season's crop to the sugar mill before nightfall. Once a back-breaking task, sugarcane has been harvested in this region for more than a century and crushed at the local Rocky Point Sugar Mill, one of the oldest in Australia. This 130-year-old mill has weathered floods, fire and storms over its long history. And today, Rocky Point Sugar Mill manager Bruce Tyson is battling his own problems.
The mill's come to a stop. We've had a failure of one of our oil coolers on the hydraulic drive on number 4 mill, and the factory's not operating now.
During the harvest, the mill operates around the clock, processing 4,000 tonnes of sugarcane each day. For Bruce to meet today's target, that's 170 tonnes every hour.
It's critical we get this plant up and going again next hour. We've got trucks backing up outside with cane on them.
Cut sugarcane dries out rapidly. And with a crop worth tens of thousands of dollars baking in the afternoon sun, time is critical.
Discover the past with exclusive history documentaries and ad-free podcasts presented by world-renowned historians, all from History Hit. Watch them on your smart TV or on the go with your mobile device. Download the app now to explore everything, from the wonders of ancient Pompeii and the mystery of the princes in the tower to the life of Anne Boleyn and D-Day. Sign up via the link in the description.
Rocky Point maintenance supervisor Terry Drury is determined to identify the cause of the breakdown.
So that's it up in the back. Looks like a whole series of plates up inside here, and that's the one that's failed. It's ruptured inside. That's a heat exchanger, a water to oil heat exchanger.
The heat exchanger cools the oil used by the mill's large hydraulic motors, which drive heavy 20-tonne metal rollers, crushing cane under tremendous pressure to extract the juice.
We can't continue to run like this because we are losing oil, and you just can't keep oil up to it, or it shuts down.
And that's not the only hitch. The ruptured heat exchanger cannot be repaired without replacement parts ordered from overseas, a delivery that will take at least 2 weeks.
So, we can't operate until we fix this up.
With the cause of the breakdown identified, Terry now has an even bigger problem: to find another heat exchanger today. At Brisbane Airport, hangar number 3 is all about heavy maintenance, where many of the flying kangaroos in this world-famous fleet come to have major service checks. Runways around the world are where 2 of the most challenging aviation feats occur on a round-the-clock basis: takeoffs and, of course, landings. One of the teams in the landing gear pit is busy installing the brakes, wheels and tyres on this A330, ready for a gear swing test at the start of the next shift. With the protective tape unwrapped from the axle, the avionics crew can install speed sensors which send vital information to the cockpit.
Yep.
Senior lamey Charles Lacina is keeping an eye on the team's progress. The job's got to be completed before the shift change, as this Airbus is booked in for a gear swing test tonight. The all-important brake units are next to be fitted.
There's 8 of these in total, 4 on each gear, and as you can see, it's a little bit more than just 2 pistons. You've got like 8 or 10 pistons all the way around, 2 different hydraulic systems. So if one system fails, you've always got a secondary backup system to apply the brakes.
The most important system to stop the aircraft are the wheel brakes. Jet aircraft have multiple wheels, each wheel containing a set of disc brakes. During landing, the brakes work hard, and therefore more brakes spreads out the workload to quickly slow the aircraft. Extreme friction from landing creates high temperatures, something these hardy units are designed to withstand. Despite being made from lightweight carbon fibre, they're still heavy enough to need a pallet trolley to move them around the hangar. No real surprise, as each unit tips the scales at about 100 kilos. To get them over to the axles, a wheel dolly does the heavy lifting, leaving 3 crew to manhandle the brake units into position. A few minor adjustments, and it's home. With the clock ticking closer to the night shift, that's 1 down, 3 to go. Back at the New Ackland coal mine near Oakey in regional Queensland, Andy Schooler is boss of a 4-day maintenance shutdown, responsible for keeping a team of mechanics on track, on time and on budget.
The best laid plans last until the first shot's fired, and then everything often goes a little bit different to how you think it would.
During the shutdown, there are over 140 jobs that need to be done.
The wash plant's made up of about 1,000 bits of individual equipment, be they pumps, conveyors, crushers, electric motors. There's lots of bits that go on in there that all have to work for the wash plant to work. So apart from your major jobs, you do have lots of those other smaller jobs, such as pump rebuilds, electric motor change out, repairs to screens. A lot of other stuff goes on apart from the big jobs.
While Andy supervises the overall operation, the biggest job on site is the removal and replacement of the jig elevator buckets, and falls firmly on the shoulders of contractor Darren McGrath.
It's not a quick and easy job, so we've got day shift and night shift on the job.
It's a busy worksite. With many jobs sharing the same equipment, Darren's already concerned about ongoing delays.
We can't do anything until this other crane gets out of the road, so the first day is always the same. Everyone wants to get everything out. We're all getting backlogged, and it's always in one little area, which is like this one, that one, and that's pipe work, but we just can't do it, we've just got to wait.
The jig elevator buckets stretch out 20 metres when fully extended. That's longer than a bowling alley. The problem Darren faces is the crane to lift the buckets can't extend its boom to over 20 metres above the preparation plant. So a plan is devised to shorten the bucket length.
We cut them in half, and then they'll come up through the roof. So then they'll go out and put them on the ground one at a time, one section at a time.
Already behind schedule, the crew are now under pressure to get the job done.
There's a lot to it to get our rigging right.
Weighing in at 10 tonnes, that's a lot of heavy metal to lift. All eyes are on the sky as the 100-tonne crane swings into action.
Fingers crossed we can get them out without any too much drama and too much wind blowing.
Good weather plays a critical role in this tricky operation. And just like threading a needle, the lifting hook lowers through this 2-metre cutout in the preparation plant roof.
When the crane comes in, we'll hook his hook onto it, he'll take the weight, and then we'll take these off. So then he'll have all the weight then.
The first of the 10-metre buckets grinds its way out of the jig elevator shaft. It's a slow operation, and the fact that it's running behind schedule is having a knock-on effect, delaying other jobs on site, which also need the crane.
We thought we'd just keep on going, work through lunch, and we'll just get the job done.
Finally, the first half of the jig elevator buckets are clear of the roof. Good news, but not soon enough. With another lift to go, this morning's delays have cost Darren and his team valuable time. 170 kilometres to the east, the temperature's still rising at the Rocky Point sugar mill. A ruptured heat exchanger has brought the site to a standstill. Bruce Tyson has been Rocky Point Mill manager since 2006, and with a customer's cane cooking in the afternoon sun, he needs a fix fast. So an external service technician is called in.
He should be here in the next hour. It's critical we get this plant going so we can get the factory going again.
Maintenance supervisor Terry Drury has been working at the mill for 10 years. He knows farmers will be harvesting cane into the night, and with a growing backlog of trucks outside, it will be difficult to catch up the lost time.
We'll try and make it up through the night, but an hour and a half's a little bit too much to make up.
Travelling from Brisbane, Rexroth external service technician Alan Osborne is responding to the emergency call. A highly experienced hydraulic specialist, he's no stranger to Rocky Point Sugar Mill.
Yeah,
good, thanks.
Yeah, we've got another leak in another heating stage there. So.
Okay, yeah, I've got a spare one with me, so.
At the end of a busy harvest season, the mill can't afford to be out of production. Terry's hopes now lie in Alan to solve the problem. The replacement parts he needs to repair the ruptured heat exchanger are weeks away. Alan will need to think on his feet and come up with a fix to get the mill back up and running as soon as possible. Working under pressure, Alan's hoping his idea for a makeshift solution will get the job done.
No, I haven't had to do this sort of temporary fix-up before, no.
Because our water comes down a larger diameter.
Yeah.
Goes out to smaller diameter, so we'll have to find something else to pick up.
A heat exchanger transfers heat between fluids. Hot hydraulic oil from the mill's motors enters the heat exchanger tubes. Cold water circulates around the tubes, transferring heat from the hydraulic oil to the water without the two fluids having to mix together in direct contact.
So the water will come in here, whatever, 20 degrees, will come out of here maybe 26, 30 something degrees, depending on how much heat it takes out of the oil.
Every hour the mill's not operational is $10,000 in lost production. Terry's hope for Alan's workaround to solve the problem is critical.
Trucks queuing up there, 7 trucks. They're waiting to dump cane, so they'll have to just stay on hold now.
Time is ticking. Before Alan arrived, the mill had already been offline for almost an hour. Moving quickly, the maintenance team carried the replacement heat exchanger into position behind the hydraulics cabinet.
It just doesn't fit into the power unit cabinet, so it's going to look a bit messy. Going hanging out the back of the power unit.
It's a tight squeeze as Alan works between hydraulic hoses and water pipes.
The mill's obviously stopped, so they're keen to get it going as soon as possible. So that's what we're working towards.
Attaching hydraulic hoses from oil cooling tanks to the replacement heat exchanger, Alan knows his temporary fix will have to hold until new parts arrive.
The other one's ruptured internally, so the oil from the hydraulic system's actually going into the cooling water. You can't leave it like that because you'll run out of oil in the tank.
Struggling to get connecting pipes to line up.
It doesn't fit, we have to make it fit. It will fit. There's no choice, it will fit.
However, Alan's sugar-coated idea might need a rethink. Heading south to the port city of Newcastle. Troy and his team have reached the halfway point, checking idlers along a 3-kilometre conveyor.
We're on the 321 stacker machine. It accepts the coal from the dump stations off the trains and stacks it into the yard.
Weighing in at a massive 600 tonnes and as tall as a 9-storey building, this metal monster stockpiles coal at an impressive 8,500 tonnes an hour. It's not long before a broken idler is discovered.
This is one of the damaged rollers that the boys have found in there. It's pretty extremely badly damaged. Yeah, that's what we're looking for when we're walking along the conveyor.
Fatigue is a challenge on a 12-hour maintenance shift.
I used to think it was a bit of a hero status to stay on there for too long, but we're in the game for a long time, so we've got to keep fresh and just rotate out regularly so you don't get them leg burns going on.
Each idler weighs 9 kilograms. Dropping into a slot on the conveyor frame,
Yeah, pinch points are a big issue when we're changing out the idlers. You've got to keep your fingers out of the pinch points so you don't drop the idler on your finger and crush your fingers or hands. Just got to be aware and keep good communications with the driver. If you've got any issues, he just pulls it up, stops the machine.
passing the halfway point, Troy and his crew are on a roll. But could the next hurdle spell disaster? The moment of touchdown, when landing gear, flaps and engine thrust reversers work together in mechanical harmony to bring one of these massive machines quickly and safely down to a taxi speed of 20 knots, roughly 40 kilometres an hour. To the east of the runways at Brisbane Airport is Hangar Number 3, a place that specialises in heavy maintenance, looking after some of the largest aircraft that make up one of the most famous airlines in the world. Inside this 160-metre long hangar, up to 3 aircraft can be undergoing extensive checks and servicing at any one time. Like this A330 in preparation of having its brakes and wheels serviced. These are the brake units, charged with the enormous task of helping to bring 187,000 kilograms worth of Airbus to a stop out on the runway. When the team have all 4 brake units in place, the wheel and tyre assemblies can roll out into position. While they continue their work on the landing gear, team leader Charles Lacina prepares the enormous wheels for refitting.
These are the lugs that drive the pads themselves, so the pads rotate with the wheels. The whole brake unit slots inside here. This part of the wheel drives the brake units. As the brake is engaged, the pads tend to slow down, which then slow the wheel down, slows the aircraft down. These are heat shields here to reduce the amount of heat going into the rim and the tyre.
For additional safety, these massive tyres are inflated with nitrogen gas to about 200 psi, far greater than the pressure used to fill tyres on a family car. Which makes sense, considering the much larger number of passengers and cargo an Airbus can haul. In total, an A330 has 4 of these 220 kilogram tyres on 2 sets of landing gear, plus 2 smaller tyres on the nose gear. Watching aircraft land, at the moment of touchdown, it's normal to see that telltale plume of smoke from the tyres.
These are the initial point of impact, all these little chevrons. They're a pneumatic tyre, so they've got a bit of flexibility so they can absorb a fair amount of impact.
To go with that flexibility, these aviation tyres also have plenty of grip. Meanwhile, the brake installation is almost complete. The team's got to push on and get the wheel and tyre assemblies on in time for a vital landing gear swing test. Back at the New Acland coal preparation plant. After a lengthy delay, the first bucket is out safely and on the ground.
First half we took out, come out nice and easy.
Despite high hopes,
We do have problems with the second lift. It's pulling out on a different angle. It's coming out and then it's got to lift straight up, so it's sort of pulling back on itself.
and already Supervisor Andy Schooler has his concerns. At a cost of $42,000 every hour the coal preparation plant is not in operation, he can't afford this shutdown to go over time.
Behind schedule at this stage, a couple of delays with getting these jig elevator buckets out, and that's impacted on a couple of other jobs that we need to lift out with the overhead crane.
Hoping for the pace to pick up. The buckets are jammed in the chute.
Got to get a crowbar in there and start levering it out.
8 hours after the job started, finally, the jig elevator buckets come free from coal handling and preparation plant number 1.
The second lift had a few dramas. which was the drive gears were actually binding up on the actual chain itself. So we just had to like take the chain and then everything sort of slid out.
Time is money. With over 50 contractors on site, a delay during these early stages of the shutdown is cause for concern. With the buckets safely on the ground, the jig elevator shaft is finally ready to be refurbished.
We'll have a night shift come on at 6 o'clock, and on some of the key jobs, the jig elevator buckets here are one.
Overnight, a 12-hour shift has worked inside the jig elevator shaft, removing steel plates. Now on day shift, the job has been handed over to boilermaker Will Hayes. His job is to weld the metal wear plates which guide the revolving jig elevator buckets. It's a physically demanding task.
Well, there's no real easy way of doing it. It's just a manual job.
A job done in challenging conditions.
It's confined space and working at heights. We're about 10 metres up from the ground. Mightn't look like it, but when you look down there, it's quite a long way.
With safety the key priority, Will is equipped with a body harness.
If I fall, it will pull me up, and then I have a spotter who will retrieve me by winding me back up if I can't just get on the ladder. There's also a risk of the atmosphere in there with all the welding and fumes. So we're constantly testing the atmosphere in there to make sure it's good for human environment. And also running a welding helmet that puts breathable air down on your face.
Another safety measure, a spotter above the chute watching Will's every move.
The spotter will generally just give me a little tug on the rope or something and say, mate, it's time to have a quick break and drink of water. It's the type of work that not everyone does. The work itself's not hard, it's just the environment that it's in which makes it harder.
After a 12-hour shift, the metal wear plates are installed and the jig elevator buckets are on schedule to go back in tomorrow. But will changing weather conditions have everybody looking to the sky instead? At the Rocky Point Sugar Mill, service technician Alan Osborne has been called in to help with an emergency breakdown.
This is a temporary solution. It'll work perfectly, it just doesn't fit into the power unit cabinet, so it's going to look a bit messy. Hanging out the back of the power unit.
Maintenance supervisor Terry Drury's hopes of a 1-hour turnaround are quickly fading.
He's actually been going about almost 45 minutes, so it'll get us going, it'll do the job, but it's not a proper installation. It's going to sit out the back of the cabinet there and be suspended on a wooden pallet, and it'll stay that way until we can get the right part.
It's a practical but not so pretty solution. As the minutes tick by, Alan looks like he might be getting close to a test run.
Yeah, he's got a couple of hydraulic pipes just to tighten up, and then just one water pipe to do, and that's it. The critical moment's going to be we run that and make sure it doesn't leak. That's going to be the most important thing. You know, as long as we've got no leaks on any joins.
At last, Alan gives the nod. It's time to test the temporary heat exchanger.
So we're going to give it a go now. We'll try it. We'll do a sequence start. We'll run these hydraulics and just check that it's all right.
As the pressure builds, looks like the mill isn't going to be back online anytime soon. Back at Port Waratah Coal Services, Stacker 321 is shut down for essential maintenance. With a window of only a few hours, this mighty machine is required back in service to unload a continuous stream of coal trains. For Troy and his crew, finding more damaged idlers is holding up the pace.
Yeah, that one's really badly damaged as well. Lost half the shell on that one. And they're the sharp shards that do have the potential to cut the belt. You've got to be pretty careful changing them out that you don't get cut yourself. That's why we wear the gloves and handle them in a safe manner.
Moving at a constant speed of 3 kilometres an hour, inspecting the conveyor belt is like being on a treadmill with the added bonus of hurdles.
Yeah, so we're walking along the return side, and you get damage both sides, but mainly on the carry side where the coal's hitting it.
Troy's team has done this job many times, but it doesn't mean the risks are any less.
There's a high exposure to potential injuries on site. We have a lot of controls in place to eliminate that. It is of the utmost importance that we protect our employees and also contractors and visitors that come on site.
After safely hurdling the conveyor belt for 6 hours and replacing 20 damaged idlers, it's the end of the line for Troy and the crew. It's essential maintenance on these mighty machines that saves millions of dollars in lost productivity. During the shutdown, the maintenance team's progress has been constantly monitored by the busy operations control room. And with the job complete, the operator has the go-ahead to bring Stacker 321 back into service. One of Brisbane Airport's largest neighbours stands to the east of the runways. Heavy maintenance hangar number 3. And getting the aircraft serviced under its massive ceilings back in the skies is what this place and its staff are all about. Heavy maintenance is their specialty, like complete overhauls of Airbus landing gear. With its brake units in place, the team is pushing to get the wheels on before the shift change, as this A330 is scheduled for a vital gear swing test tonight. With each one weighing about 220 kilograms, their installation will not be as zippy as a pit crew working the Grand Prix circuit. Lining up the slots of the brake pads with the lugs inside the wheel rim takes time, patience and expertise.
I just had to come down a bit.
Down a bit?
Try something there.
Alright, wait there, the straps.
Holding.
Hold it there.
Bit by bit, the wheel is eased into place. Next, the wheel nut. Time to put a torque wrench to work. With 3 more wheels to fit, under the guidance of experienced lamies, practice definitely makes perfect.
Just got to line up those lock bolts. There's a couple of lock bolts that go through here, so just line up the hole. So once we got the torque, we tighten it up to line up these lock bolts.
With the brake units and wheel assemblies installed, the team have met their deadline, ready for the night shift to carry out that all-important gear swing test. Just one of the many work assignments to be successfully and professionally completed under the towering ceilings of hangar number 3. At a work site that never sleeps, a new day has dawned under grey skies, and a weather forecast of wind and rain has Andy concerned.
All the planning in the world, you can't always see these unforeseen weather events, and you throw people into the mix too sometimes, and you always get these challenges.
And there's always that constant reminder of what can go wrong.
I wasn't actually here at that time, but I think you'll find it was probably the wind picked up then and blew the load, put a bit of a dent in the guttering on the plant.
In the coal preparation plant, final work is underway for the replacement of the jig elevator buckets.
I guess we're getting to the pointy end of the shut, if you like. The end's in sight, and the fellas probably got a bit more emphasis on getting in and getting the jobs done.
The first of the new buckets rises into a threatening sky. All eyes are on the weather as they pass the damaged gutter. Weighing in at 10 tonnes, the buckets thread through the rooftop. Hanging from chains, they are slowly lowered by the crane. Gradually, the buckets are carefully guided into the open chute.
Probably take an hour in each one. Plan on an hour in each one, yeah.
But there's a problem. something has stopped the buckets. Aware the wind could pick up this afternoon, an hour is too long for Andy to wait.
Would have liked to have seen the buckets in by now, that's for sure.
They need a solution, and fast.
One of the wear strips didn't quite have enough chamfer on the leading edge, so the buckets were catching on a limb.
Eventually, with some persuasion, the buckets finally lower into the chute. And while the pace has picked up, so has the wind. Five stories up, the crane is struggling to lower the jig elevator buckets through the access port in the preparation plant roof.
Yeah, copy. We might have to bring those buckets back down to the ground. We're trying.
With strong wind gusts risking the safety of his team, Andy has made the call to halt the install of the jig elevator buckets. It looks like the weather has won the battle, this time.
Once that load started swaying from side to side, the fellas didn't have control of it with the guy rope. I didn't want that to keep going with the job at that stage.
Crane operator Trevor Sharpley and rigger Russell Whitby agree with the call.
Russell said it's pretty windy up the top because you don't know till you get it up past the building there, and then it's gusting.
We just couldn't hold it still enough to get it to feed into the hole. There's an antenna and some aircraft lights up there that, yeah, they're pretty close, so you just got to be careful you don't hit into them. So, yeah, I was just worried that a gust would take it.
With the continuation of the job now relying on a break in the weather, some serious decisions have to be made if Andy is to continue past the shutdown deadline.
So we've had a look at the weather, and we probably expect these winds to hang around for the rest of the afternoon.
Pushing one day past the deadline means over $1 million in lost production. But there is a backup plan.
If we can't lift these up today, we'll look at coming in at 4 o'clock in the morning at daylight. Generally get a couple of hours period there where there's no wind.
A good solution, but one that creates another problem.
Because a lot of these people have got other jobs they go to after this one. How are you going, Cameron? We've only had them booked for the 4 days, so they make other arrangements, and so I'll have to do a ring around and see who I can get to stay back and work on the job.
Running over schedule and battling the elements will be a costly delay. But will Andy find the manpower he needs to get the job done? At Rocky Point, the sugar mill is still offline. Hydraulic specialist Alan Osborne is desperately trying to stop a leaking water pipe on his temporary heat exchanger.
Bit of a water leak, just one of those things, but I think we've got it sorted now.
Replacing a rubber washer has fixed the water leak, and the pipe is reconnected to the cooling tank. With hydraulic hoses checked and water pipes securely tightened, Terry can finally restart the mill.
So, as you can hear now, that pump started up, so that'll start to use that system straight away. So, we'll check that for leaks now.
Once we go around the back of the door.
I'll have a look through here. All looks good, Al? Yeah, looks good, yeah. That's good.
Terry's happy. At last, the large hydraulic motors which drive the crush power up.
So no leaks on our preliminary start. So now we'll start up the milling train so we can start crushing again. That'll put it under full load. We'll recheck it again.
Before Alan can leave, the mill has to be working at full operation.
This shows you when these rollers and all that start up. So the ones down there have started, the green ones. Now this is the mill that we're standing at, this colour here. So it's about to start.
As he brings the mill back online, Terry is on the lookout for problems.
This is the mill where we placed the oil cooler on, and it's now working under full load, so we'll check that now.
Mill boss Bruce is keen to get a report.
Seems to be going all right. We've checked for oil leaks. Looking from this side, no oil leaks. Alan's looking outside, I just asked him, so there's no oil leaks at all, so the water leaks fine, so it looks good.
Excellent, we're up and going again.
Yep, happy.
Thank you.
Alan's temporary heat exchanger has saved the day. Hoping to be back online in 1 hour, Terry delivers Alan his report card.
From when we shut the mill down to when we got going again was just over an hour and 50 minutes, so really it's pretty good. You know?
Yeah, that's pretty good.
You always hope for better than what you can actually do.
Yeah,
So.
and we always have the little water leaks, you know, that probably cost us 20 minutes.
Yeah, easy.
Otherwise it would have been up and running on schedule. But anyway, main thing is you're up.
Appreciated.
No worries.
And really good job.
Okay, thanks very much, Gary.
No worries, mate.
All right, we'll see you next time.
Yeah,
Thanks,
well,
man.
One day over the scheduled 4-day shutdown, and Andy has managed to gather enough men to continue the job. High winds yesterday delayed the lift of the last jig elevator bucket.
Yeah, the boys came in at 4 o'clock. The wind has died down by that stage.
Now, as day breaks, the final bucket is safely lowered through the coal processing plant roof.
Obviously, we've overrun our scheduled time. We were hoping to be up and running this morning around 6 o'clock, but if we had had the elevators in by 4 o'clock yesterday afternoon, we would have achieved that.
1 day over schedule, and with a handful of contractors on site, Coal Handling and Preparation Plant number 1 is back in production.
To have a successful outcome for a shutdown, you rely on your people you have working here, whether they be our mine employees or our contracting companies that come in and do the work. So we're very fortunate. We have some really good people. They get in and have a go and they care. They have pride in their work.
Andy and the New Ackland Coal Handling and Processing Plant team have managed a challenging operation. Risking an expensive overrun, Andy's focus is safety first. They've battled the elements to get millions of dollars of machinery back online with the expertise and coordination of a team of experienced mega mechanics. Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, trek out back to the New Ackland coal mine, where temperatures are soaring and an old hand on the tools, Steve Frosty Frost, is faced with a new challenge.
Being a bigger truck, everything's a bit bigger and heavier.
A huge engine needs a change out, but an unscheduled delay means it will take more than just manpower to move this mass of horsepower.
The big crane we were expecting this afternoon got double booked.
The stakes are even higher, or rather heavier, at the Broadwater Sugar Mill, where lead fitter Peter Hewitt is guiding his team through a dangerous lift.
If one of these fell, there'd be a hell of a lot of damage.
With only a few days remaining to strip the mill, he's feeling the crush.
Under a bit of pressure at the moment.
Senior licensed aircraft maintenance engineer Patrick Donoghue must restrain the full power of an A330 Airbus to test the engines.
Okay guys, we're going up in power.
Both jets must pass strict engine run procedures, and the team's in for a bumpy ride.
99.07, here we go.
From planes to trains, meet the spin doctors of Queensland Rail, like rolling stock technical advisor Ben Noakes.
There's the book, and then there's experience.
Shaving steel wheels into shape under 45 tonnes of rail car is how the City Network rolling stock maintenance team roll, ensuring the safety of thousands of commuters.
If we can't provide the train, people don't move.
160 kilometres west of Brisbane, near Oakey in regional Queensland, is the New Ackland coal mine. Here, the largest truck in the fleet is the Caterpillar 793. Weighing in at 380 tonnes with a top speed of 60 kilometres an hour. When one of these yellow beasts is fully loaded, it's like driving a two-storey apartment down the road. Keeping a fleet of mine trucks running like clockwork is a constant challenge and relies on a team of mechanics to maintain these mighty machines 7 days a week. Steve Frost, known to the crew as Frosty, has been working on heavy machinery most of his life. He's an old hand on the tools around here, but that doesn't mean he's not up for a new challenge.
This is the first time we've taken an engine out of a 793 truck here. So it's all a bit new and exciting. A few different things to the other trucks. Of course, being a bigger truck, everything's a bit bigger and heavier, so there's some challenges there as well.
This Caterpillar 793 mine truck has come in for an engine replacement. A new low compression engine is on standby for the swap over, offering improved fuel consumption and lower noise levels. This Cat C175 engine is a 16-cylinder 4-stroke quad turbocharged diesel engine, packing gross power of 1,976 kilowatts or 2,650 horsepower, driving a 6-speed automatic transmission. Weighing in at 12 tonnes, this massive engine will haul 200 tonnes fully loaded. But there's no time to boast over impressive specs. Frosty has to have this truck back in the pit, hauling overburden and coal in just 3 days.
Production always up is to have the trucks back in service, so it's pretty crucial we stick to the timetable.
Field service fitter Joel Oxenbridge is on site to handle the changeover of this massive 16-cylinder engine.
This is one of the bigger challenges that we've had in this district, pulling out an engine of this size.
Rounding out the workload is Harry Mitchell, a specialist mining engineer. Working on an engine this size can be an intimidating task.
This is my first time taking out one of these engines, so it's going to be a bit of fun seeing it lifted out. Good experience.
As the Caterpillar specialist, Joel is the leading hand, preparing the engine for removal.
What we're doing is just sort of start taking off all the lines. We're just going to take off anything that's sort of going to hold us in.
A job that requires disconnecting the radiator, fan and hoses to drain the coolant and engine oil. Also loosening and unfastening hundreds of electrical wires.
Anything that's going to attach to the chassis rails and anything that's going to hold us back from the back side in.
Before they can finally remove larger components such as steering pumps, exhaust manifold and transmission, Joel's taking the practical approach.
I think we'll start at the top and work our way down.
And down is where you'll find Frosty, working underneath the engine.
Got one bolt there, it's a bit tight in the threads.
Experience tells Frosty if it's rust, that just calls for a new bolt. But if the threads are damaged, that could mean an expensive replacement pump.
Pump's probably run into about $10,000 or $15,000. So hopefully it all comes out all right.
With a costly pump motor hanging on the turn of a thread, Frosty carefully shifts the spanner above his head.
Got it. There's a lump of dirt on him. It's holding him up. That's good. No new pump needed.
With so many moving parts, even the smallest bolt could bring the entire job to a standstill. Weighing in at 12 tonnes and about the size of a small family car, it's going to take more than manpower to move this mighty horsepower free of the truck chassis. To remove the engine, a large slew crane is scheduled to arrive on site to lift the load clear of the truck. Knowing this, Frosty and the crew are under pressure to ensure all parts are unfastened and will clear the engine bay.
Hopefully we'll have all this disconnected next few hours. Should be ready to pull the engine out this afternoon.
But Frosty's plan for a punctual engine lift could be left swinging in the breeze. The crew has received a message from the crane company.
There was sort of talk that there could have been a low on a driver, so we mightn't get a big enough crane to pull this engine out this afternoon.
To stay on track with the schedule, this massive engine has to come out of the truck before the end of this shift. Pushing the deadline is not an option the crew wants to face. But ever resourceful, Frosty has an idea that may just save the day. Sometimes it's the little things that can make a huge difference. Over 300 kilometres southeast of New Auckland, the Broadwater Sugar Mill has been crushing sugarcane since opening in 1881. During harvest from June to December, the mill operates around the clock to produce over 1 million kilograms of sugar every year. There's a lot of load on machinery. There's a lot of moving parts and a lot that can go wrong. Something engineering manager Stephen Wagner has had to deal with throughout his extensive career.
Been working on this site for 37 years, most of my working career.
Stephen knows the mill has taken a battering from 6 months of crushing sugarcane around the clock.
The process is basically very simple, but there's a lot of complexities that sit behind it.
Milling is the process of squeezing juice from sugarcane between heavy cast iron rollers under high pressure in a set of mills.
There's 4 mills with 6 rollers in each mill. Each roller weighs about 20 tonnes. And then we have 2 hydraulic cylinders on the top roller, and we actually loaded up about 1,700 tonnes of hydraulic force to squeeze the juice out of the cane.
The mill rollers are made of a 2 metre long solid steel shaft, covered by a 1.1 metre cast iron shell with deep grooves. Sugarcane is crushed between the grooves to extract juice. Every hour, 250 tonnes of cane is processed through the mill in an around-the-clock operation.
So the cast iron shell is a consumable. We actually wear it away 25 to 35 millimetres each year. It actually gets smaller and smaller. And then after 6 or 7 years, we take it out. We'll send that away for repair.
The sugarcane season might be over, but work doesn't stop. The mill is now in a period known as the slack.
Each year in December, we completely dismantle the mills, and then we rebuild or replace the componentry that needs doing for each of the 4 mills.
Stephen's workforce and his pre-planning for the slack is about to be put to the test. The plan today is for lead fitter Peter Hewitt and his team to remove one of the 20-tonne crushing rollers from the mill.
Big challenge is heavy lifting. Not much room to move it, to get it out. You've got crushing and pinching. You can catch on to things. So you just got to watch the item you're lifting out and make sure no one's underneath while you're lifting, and we stand clear of the load while it's up in the air.
The on-site gantry crane is working overtime as equipment weighing tonnes is shuffled around to clear the way for the enormous rollers to be removed.
So on your lifts, things may get in your way that you don't think of, and you just got to work around it. We've got a good crew, so they know what they're doing.
Meanwhile, preparation to remove the roller has begun, and years of bearing grease is scraped away. The 30-tonne gantry crane is prepped for the lift, and the rigging procedure is carefully planned to ensure the roller will be properly balanced when the lift commences.
If one of these fell, there'd be a hell of a lot of damage to plant equipment, as well as if someone's underneath it, there's not much chance for them.
Finally, the gantry crane is rigged and in position above the 20-tonne roller. With the load secured, the lift is underway. It's a weight similar to a double-decker bus, And the task Peter faces is just as difficult as reverse parking one.
Hey, hang on, Dave.
Peter's quick to spy a chain that's caught.
Sorry, mate. Just go easy, touch. I didn't notice the chain lock was getting caught up there, mate.
One quick flick and it's free.
Right. Right, you're right now, mate.
But he's not clear of the mill yet. It's a slow precision task. One slip of a chain or tight corner brushed too closely could be disastrous. The headquarters for Qantas A330 and 737 heavy maintenance is at Brisbane Airport Hangar 2 and 3. This custom-built facility can park 3 aircraft wing to wing. Work here is run with meticulous precision by dedicated team members like Senior Licensed Aircraft Maintenance Engineer Patrick Donoghue.
I have been working on aircraft in Qantas for 28 years. I can always think that there's thousands of people flying in the aircraft that worked on it, and they got from A to a Z safely. It's just personal, really. I make sure everything's done correctly.
Patrick's job today has him preparing to run the jet engines of this A330 Airbus. The aircraft cannot be cleared to fly until engine performance is thoroughly checked while it's safely on the ground. Equivalent to restraining the combined horsepower of more than 20 Formula One cars at full throttle. But there's a lot to do before Patrick can unleash the power of these jets.
6:30 in the morning when I turn up to go over an area of my responsibility and check to make sure that it's safe. Qantas is very, very strict here on safety.
Every 18 months to 6 years, an aircraft will be taken out of service for heavy maintenance checks. This work is imperative to assure the safety of passengers and crew, and meticulous planning is required to ensure it happens within strict schedules.
Obviously, if there's a mechanical issue, we have to fix it. We can't let it out without fixing the defects, but passengers will be waiting for this aircraft tomorrow morning at 7:15.
One final box to tick in the maintenance schedule will test the performance of the A330's 2 General Electric CF6 jet engines at full thrust. Weighing in at 2 tons and costing millions of dollars, the jet engine is what keeps a plane flying. Air is sucked into the engine through the fan blades, then into a compressor. The compressed air is mixed with fuel and ignited in the combustion chamber. Hot exhaust gas comes out of a nozzle, thrusting the engine and the aircraft forward. Patrick must sign off on these engines being fit for service and meet the strict criteria set by the airline. Safety is priority, and the crew run through the procedures in the event of an emergency.
Is everybody aware of the processes? In the event of a fire, etc.? Now, Mark, you're in charge down there. Can you tell me who's on the aircraft?
It's just us 3 in the cockpit.
Us 3.
Me and Kelvin. So
Right.
It's 5 total.
So any issues? Myself and Al will give instructions on what to do. You've got to familiarise yourself with the cockpit. You've got to read up on the instructions. There's various scenarios can happen up there. You could have an engine fire, you could have an APU fire, you could have a fuel spill. You've got to know what to do.
For this test, Patrick might be in the captain's seat, but he's not alone on the flight deck.
Thank you. I have an experienced engine runner always on the right-hand side. I've also got an avionics technician with us who is appropriately trained. And combine the 3 of us, we have enough knowledge to do whatever happens.
We're ready for hydraulics, mate.
Al, you ready for hydraulics? Yeah. Okay, clear.
With his team assembled and initial checks completed, the aircraft is ready to move to a safe location outside the hangar to be powered up.
Hello, ground. Hello, Paddy. Are you ready to go? We are ready to go.
If I can confirm, brakes are off. We're clear.
All right, okay, stand by.
Outside the aircraft is Mick Little, licensed aircraft maintenance engineer in charge of ground operations for the engine test. In constant communication with the flight deck and spotters on the ground.
It's got a lot of momentum, you know what I mean? If we do roll and we do accidentally hit something, we're very, very quick, you know what I mean, with grabbing and stopping.
His first challenge is to safely manoeuvre this huge aircraft out of the hangar. It's a crucial few minutes. And slowly but surely, the aircraft is pushed out onto the tarmac. And Mick's taking no chances. Spotters are on hand to ensure no part of the aircraft will impact any of the hangar's structure on exit. The tug moves the plane to an area clear of the workshop.
So we've got some quite substantial, big, strong chocks in there to stop it from jumping, but there has been situations over the world where other airlines have unfortunately, during engine runs, jumped chocks.
With 180 tonnes of Airbus to hold back, these chocks, along with the brakes, have their work cut out for them. Safety always comes first. The aircraft might be due back in service tomorrow, but it's a job that can't be rushed. As always, there is the risk of the unknown.
We could have a fire on the engine.
The possibility of an engine fire is never ruled out, but the slightest indication of trouble would immediately have Mick contact the flight deck, see the throttle pulled down and the test crew safely evacuated. The question still looms: will these engines pass or fail? 12 kilometres southwest of Brisbane Airport is an equally busy transport hub, Queensland Rail's main maintenance workshops. To keep the trains running on time, this place runs 24/7, maintaining a huge fleet. With more than 200 of these 72-metre-long rail cars on the books, the rolling stock maintenance team are always on the go, just like the 45-tonne carriages they regularly service. After a stint in the Navy, technical advisor Benjamin Noakes swapped to the high seas for solid ground. Riding the rails comes very naturally. In fact, it's something that runs in the family.
I'm second/third generation railway. My father's been here for close on 40 years. I've been here for 8 years.
With that kind of pedigree, Ben knows only too well the daily pressure that comes with keeping trains literally on track. Keeping the wheels in motion is what Ben and the maintenance team specialise in.
We've got a set amount of trains we need to provide each day to enable to run the peak. So in our great machine, you've got drivers that expect a train to be there, people expect a train to be there.
Inside this shed is the machine in charge of delivering a smooth, safe ride. An underfloor wheel lathe that accurately shaves steel rail wheels back into shape. A train wheel is beveled to make it wider on the inside. This means that when the train shifts left or right on the track, the diameter of the wheels can change. But because the wheels are connected by an axle, they still spin at the same rate. Effectively, this means that when turning, the wheels will travel different distances per revolution. Rolling along 850 kilometres of suburban tracks means these steel wheels are subjected to constant wear and tear.
Over time, metal-on-metal contact results in wear. So you need to bring the wheel back to a profile to enable it to continue running on the track, to go through things like points and around curves.
On the Brisbane suburban fleet, each 3-car train has 12 wheel sets supporting up to 150 tonnes. Ensuring they're in prime condition is a top priority.
There's a groove cut into the wheel. This is about the condemning mark on the wheel, which is about the minimum size. So the life of your wheel is that much metal.
The next train to roll over the underfloor wheel lathe has a wheel set displaying symptoms of thermal cracking. As the maintenance crew set up the machine, deadlines are tight, and this train is required back in service later today.
The pressure's pretty constant, so they got to be maintained well.
Trains and timetables go hand in hand. Keeping hundreds of thousands of commuters happy and on time is a daily challenge. A challenge the maintenance team must meet between the morning and afternoon rush hours. So racing the clock is a daily battle for the crew. With rush hour approaching, it's a job that can't run over schedule. At the New Ackland coal mine, a mighty Cat 793 mine truck is in the workshop for an engine replacement. And some disappointing news puts Frosty into troubleshooting mode.
It's a big crane we were expecting this afternoon. Got double booked apparently, and we're not getting it. It won't be available till the morning, so we'll try and use our little crane to do it.
But will his optimism pay off? Can a smaller crane handle the load? Dave Sipple drives it over to the site to find out. The crane positions the boom directly above the engine. It's a cautious time, as distance and load capabilities must be precisely calculated.
The crane has limits, and the further you telescope the boom out, the less you can lift. You know, you don't want the crane to counterbalance on the front wheels and do a nosedive or anything, so we'll just have to test and see if we can carry the load at the distance we have to.
Safety on site is a high priority. While the crane might have the muscle to handle the weight, it's the outstretched boom arm that's worrying Dave. There's no room for guessing with machines and loads this large. Throwing the crane off balance would do some serious damage to equipment and potentially injure the workers.
I think it's a bit too far for us, mate. I'm going to be about 4 tonne over from where I'm sitting, yeah.
The engine isn't going anywhere today. As much as Frosty wants the job to keep moving, so this truck can be back in the pit earning its keep, safety is more important.
We're not going to be able to use our crane, unfortunately. We thought we might have gone close, but it's a bit further reach than we'd hoped for, so it's just not going to work for us. I was looking forward to lifting it out today, but it's not to be. So we'll just have to suck it up, have another go tomorrow. Well, who knows what can go wrong.
Big lifts are also on the cards at the Broadwater Sugar Mill. The crushing season is over, and as part of the site's annual overhaul, lead fitter Peter Hewitt is supervising the intricate removal of some of the heaviest mill equipment. The risks and responsibilities of the job sit firmly on his shoulders. So he's constantly checking for pinch points and anything protruding that could catch the 20-ton roller, throwing it off balance and crashing into the mill below. It's a tight squeeze, and Peter knows this is the point in the lift where rollers can become stuck. One false move by the crane operator on the controller could be disastrous.
Nice and steady, eh?
And with one final lift, it scrapes through within millimetres. Slowly, the 20-ton mill roller travels across the mill below the gantry crane and down to a safe resting position.
Off the bed, pretty close to being center. Come down.
This roller needs to be loaded on a truck this afternoon, heading north to a foundry to be reshelled with new grooves. But there are more tasks to complete before this massive roller is moving anywhere.
Now we've got the roller out. These brasses, which are the bearings, they've got to come off. So we'll use a crane to drop them to the ground, and we'll strip the roller completely. So all these wear rings need to come off. There's some lip seals under here that need to come off, and we'll clean it up. And I'll go and measure the journals underneath the brass, get the diameters on that, measure the diameter of the roller and the width of the roller, just so we know how it's worn from beginning of the season to the end of the season. Once that's done, we're going to send it away to get reshelled, get a new roller.
The bearings may not look like they require a crane lift, but being made of solid brass, these pieces weigh hundreds of kilograms. For a mega mechanic, a crane is just another tool in their repertoire. These rollers are the workhorses of the mill and are often where breakdowns will occur.
They break under fatigue in operation, so that causes an operational shutdown of about 2 days. All the maintenance crew will come in and work around the clock to change those rollers out to get us going.
The constant workload the mill is subjected to means serious maintenance. But if Peter can't get this roller stripped before the truck arrives in the next hour, this enormous roller won't be going anywhere. At the heavy maintenance hangar in Brisbane, senior licensed aircraft maintenance engineer Patrick Donoghue has the equivalent power of more than 20 Formula One cars at his fingertips. He's preparing to put an A330 through its paces, with a final engine assurance run at the end of a 21-day maintenance service.
Windows closed. Your windows closed on, mine is closed.
On the ground below, Mick Little acts as the eyes and ears for the crew on the flight deck.
Couldn't close down there, Mick.
Everything's clear and ready to go.
Right, I'll get back to you.
Standing by.
Thank you.
It's Patrick's responsibility to ensure everything is checked and checked again. Mandatory processes and lists of more than 100 procedures are in place to ensure nothing is missed. The takeoff thrust of one of these aircraft could propel the plane to speeds of more than 580 kilometres per hour, or more than 160 metres per second. So Paddy thoroughly cross-checks procedures.
Pre-start checklist complete. Tick. Ground clearance we've cleared. We're starting number 1 engine. Ignition start. Are we okay, Mark? Keep your eyes out. Confirm N1 rotational.
N1 rotation.
Starter code out at 50%. Confirm.
Beginning on the left engine. N1 means the rotation of the fan blades. As engine speed increases, the wheels are firmly secured with chocks and the brakes enabled to prevent the plane moving forward.
Starting number 2 engine, guys.
The right soon follows, and both engines are left idling for 5 minutes. Engine parameters must be checked before the engines can be pushed to full thrust.
22.3 and 22.4. EGT 360, 360.
N2.
61.6, 61.6.
Fuel flow.
550, 540.
Oil quantity.
18.5, 17.4.
It's a passing grade. The first hurdle cleared, but that was the easy one. After being inactive for 21 days, it's time for this Airbus jet to do what it does best. Roar into action. Time for Patrick to push the throttle and run the engine all the way to 100% to ensure the maintenance team's hard work has paid off. At Queensland Rail's main yard in Brisbane, the underfloor wheel lathe crew are preparing to put the wheel set under the knife, a 4mm metal alloy cutting tool designed to precisely shave solid steel train wheels back into shape.
No day is the same, no defect is ever the same. A lot of experience required for the operators to know how to deal with the defects, how much material to take off the wheel, and your job is trying to get as much life out of the wheels and get the best operating cost out of them.
As its name suggests, the underfloor wheel lathe is housed down in what looks like a mechanic's pit. To get the job started, the operators wrangle the carriage into place.
They first have to move the train to the right position on top of the cutting tool, align it, do a scan of the wheel, so to figure out how much wear it actually has. So they're actually physically beneath the rails and working underneath the train, machining the wheels whilst they're in the train.
With 45 tonnes of train car directly above them, safety is always a high priority.
There's always risks in operating heavy machinery, but it's all about how they're managed. Specifically over here, you've got the swarf, or the machine bits that come off the wheel. They're razor sharp.
For safety, eye and hand protection is worn, as is hearing protection when the machine is lathing the wheels. With everything set, the team can now start the process of scanning.
There's various sensors in the lathe that'll actually take a scan of the wheel, and the wheel is of an expected shape. So it'll take a scan of that and then compare it to the required shape, and it'll give you a difference, and it will calculate how much it needs to take off the wheel to enable it to get back to the correct shape.
Just a small amount of tread wear is discovered on this set. Only fractions of a millimetre difference is a good result. Some thermal cracking is discovered, which is commonly caused from friction. Left unchecked, thermal cracking can cause the formation of holes in a wheel. And defective wheels mean a rough ride for passengers. That's where the Atlas Rail lathe intervenes. It's technology designed and built in Australia, precisely shaving mere millimetres that make a huge difference on the tracks. The team have decades of experience and they agree with the computer's findings. So it's time to put the lathe to work. It's a big job, and this is just one of 12 wheel sets to get through. Will the team be able to stay on schedule and get this 3-car train out on the tracks for the afternoon rush? It's a new day at the New Acland coal mine in regional Queensland. After yesterday's disappointments, the large crane that was due to turn up has finally arrived on site at 7 a.m. this morning. With a load capacity of 40 tonnes, this crane has enough lifting power to remove the truck's 12-tonne diesel engine. With everything disconnected, the engine is ready to take flight. Rigging the lifting hook with heavy chains, rigger Russell Whitby and crane driver Trevor Sharpley are regularly called in for the big lifts at New Acland. With the chains attached, Joel prepares to undo the engine bolts that hold this heavy metal beast to the chassis. Frosty is desperate to make up for lost time.
Crane's hooked up, we've got the engine mounts undone, so we've got to lift the front of the engine first so that we've got clearance at the back to lift the whole thing out as one piece without fouling on anything. So pretty much ready to go now.
With the boom positioned directly above the engine, Russell makes a final check of the rigging.
Oh mate, everyone's clear, no one's going to get hurt, no fingers in the way.
Trevor is responsible for operating the crane and works closely with rigger Russell to guide him through the lift.
Yeah, just making sure that nothing's going to get caught up, break anything off, or all the bolts are out, everything's loose. Just everyone eyes on the task.
Righto mate, we're going to lift it out.
The lift begins with caution. But there's a problem. The engine's not moving free of the chassis. Crane operator Trevor lowers the engine, releasing the load. The men are frantically looking for a hose, a bolt, a clamp, anything still attached to the engine bay. Joel spotted the problem. A small hose clamp weighing less than a few grams has caught up the mighty 12-tonne engine. Slow and steady, the lift is on again. It's all eyes to the sky as 12 tonnes of cat power rises into the air. This is where the crane really shows off its lifting power.
We're going to set the engine up on stands. We had to go and rob them from under a dozer in the workshop, so hope no one notices.
We're going down.
The engine is finally out of the truck and on the ground. Now a full day behind schedule, Frosty and the team have no more time to lose. The crane will be back on site tomorrow morning at 7 a.m. Racing the clock, the new engine must be prepped and ready in time to go back in the truck. The pressure is on for this job to be as efficient as possible to get the truck back in the pit and back into production. But right now, it's going nowhere without an engine. The team at the Broadwater Sugar Mill are in the process of dismantling the 4 on-site mills in order to completely overhaul the facility, ready for next season's crush. The maintenance work is integral to the functioning of the mill, and countless tasks need to be done, from pulling down overhead platforms to dismantling drive shafts. It's dirty and strenuous work, and there's always a multitude of jobs to be done.
Very interesting industry, very good training ground for young engineers, young tradespeople and process operators.
Meanwhile, on the other side of the mill, young apprentice Caitlin Vlahos is busy preparing for more roller removals.
So I'm taking the hydraulic hoses off the Haglin drives and blanking them off so they don't get contaminated. So later on we'll take these Haglins off the mills so we can take the rollers out. We're under a bit of pressure to get it done safely and efficiently.
For Peter and the team, the day has had its challenges running to schedule. Stephen Wagner knows from years of experience exactly what makes this mill run.
The most important thing is to have the right people in the right places, and they all do their jobs and they know their jobs. That's what's really important, because at the end of the day we're a team and the team needs everybody to do their bit to make the place function.
Peter made his truck delivery on time and the roller was ready to be sent north to be reshelled. Over the next 6 months, the mill is completely disassembled for maintenance and the entire operation reassembled once again for the new season's crush, a routine at Broadwater Sugar Mill for over 135 years. The A330 jet engines have passed their idling check and are ready to be pushed to maximum power. The left engine is the first to roar into action.
Okay, we're ready to go.
Okay, guys, we're going up in power. Okay, clear, Paddy, clear.
Mick, okay, clear. Mark, you right?
Yes, mate.
Al, 99. I'm going up, coming in figures again. I'm going up on the right engine first, the balance engine, 83.43.
83.43, yes.
So what we'll do is go up slowly. 83.4. We get that setting first?
83.43, yeah, if you want to do that on both, and then we can just go straight up to 99.
That's okay, within limits there.
Yeah.
Now, time to really push them.
99.07, here we go.
On the tarmac, the chocks have got their work cut out. On the flight deck, they're really feeling the vibrations, getting more intense with every second.
Okay, we're going to leave it here. 2 minutes. Tell me when the 2 minutes is up.
That one engine is really shaking things up. As it winds up to full thrust, the immense power rocks the plane, letting the engineers know who's boss. At full throttle, these 2 turbulent minutes seem endless for the testing crew.
Tell me when it's up.
4, 3, 2, 1. 2 minutes is up.
Coming back on power, guys. Just let it settle down, bottom. Then we go up, we do the same on the right engine. Michael?
Copy.
Any leaks?
No leaks. All clear, all clear.
Okay.
Success.
We're going to do the same on the right engine within a minute. Are you okay?
Yeah, clear.
One engine down and one to go. Time to check procedures and prepare for a second engine run. Will this one have the right stuff and pass with flying colours as well? Meanwhile, at the Queensland Rail Workshop, the maintenance team are putting the underfloor wheel lathe through its paces. The lathe guides the machine's metal alloy cutting blade to precisely shave away defects from the wheel, like those caused by thermal cracks, with the operator on standby to clear out the razor-sharp curls of swarf. More filing shaved off by the lathe means a more comfortable ride for commuters.
Wheel machining on trains is experience. There's the book, and then there's experience.
Using a profile gauge, the lathe's progress is checked. With the machining on this wheel set nearing completion, the maintenance team train their sights on the next pair. Thanks to their work, passengers are in for a smooth ride, which gives the team at City Network Rolling Stock Maintenance something to be proud of.
The challenge, every day at turning those trains out, skill, pride and professionalism, really.
At this pace, the team will have this 150-tonne train ready to roll, right on schedule for the PM peak. Back at New Auckland, a costly delay has the team running 1 day behind schedule. Final preparations are underway to get the new engine ready for the lift. Mechanical fitter Frosty is keen to get the truck operational to avoid further delays so it can get back to the pit and into production where it's urgently needed. With the 40-tonne crane back on site, everything must run smoothly to get the new engine into the truck. It's a balancing act between Frosty and Russell.
Yeah, I've got about a foot we can go down.
As Frosty carefully manoeuvres 12 tonnes of engine into the chassis.
Rightio, come down. Happy? She's in, the engine's in. Just a matter of doing up the mounts now, tightening everything up, plumbing it all up, hooking up all the hoses, torque converter and everything.
Frosty might be able to breathe a bit easier.
No way, it's not gonna. Just move the top towards me, so you move the back out towards you. We go down a bit.
But he's not out of the woods yet. There are many hours of work ahead, reconnecting hydraulics, electrical, and piecing the truck back together before it's ready to start hauling loads.
Been a bit of a hectic week. Had a few delays. Train not turning up on Tuesday blew the whole schedule really. But we got the engine back in now, so we're pretty happy with that. See you guys. Thank you.
It's a tough job with a lot of pressure, but Frosty's not the kind of guy to let it weigh him down.
It's pretty good. It's good fun. Makes a bit of a laugh. If you can have a laugh and still get stuff done, it makes for a good week.
But when it's all said and done, with hoses reconnected and connections tightened, will the new engine start and run?
Pretty confident when they go to push the button, it'll all be pretty sweet.
Making this Cat 793 mine truck set to roar back into production in the pit. Outside the heavy maintenance hangars in Brisbane, Patrick Donoghue is about to push the throttle on a second engine run up to full thrust.
Okay, Mick, we're going up on number 2 engine, all clear.
Once again, the engineers feel the raw power of just one A330 jet engine. Shaking not just the cockpit, but the entire 60-metre long aircraft.
Okay, 2 minutes is up. Coming back down to power, guys.
Another excellent result. And the engine assurance test is over.
Brisbane ground, this is Echo Bravo Victor. We've completed our high power runs on Mike 3, thank you.
Everything checked out okay. Both engines passed. We're on the way back to the hangar now. We are ready to move when you are.
With both jet engine runs a success, Patrick can now sign off on this component of the aircraft being ready for service. But the job is not over.
On completion of engine runs, the plane comes back to the hangar and we open all the cowls and the fan cowls and we get the guys in to just quickly have a look at all the fronts of the motors for any sort of debris and stuff like that. The backs of the motors, we check all oils, fluids, and also anything that we change on routine maintenance and non-routine maintenance, just to see if everything's intact.
Not only enormous in scale, detail and technology, the hundreds of thousands of moving parts in this A330 is staggering. And Patrick, Mick and the team check, test and maintain every square centimetre of it, which ensures passengers stay safe while flying.
Every day we do this sort of thing and it's very second nature to us, and we do a lot of training to ensure we're up to date with everything, and also working with our Brisbane Airport Corporation as well, make sure we're adhering to all the rules and regulations. Yeah, get out there and do our stuff and bring it back in safely. I'm very, very honoured, very, very proud to work for our national airline.
True to schedule, there were no delays getting this A330 back to its gate. Thanks to this highly skilled team of mega mechanics, passengers can once again take to the skies on board this Airbus and safely travel the globe. Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet, doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, at the world's largest coal export terminal, leading tradesperson Darren Westwood has a massive 23-tonne gearbox in full swing.
Those coupling bolts have been in service now for 18 years.
And it's a bolt to the finish to get this mighty bucket wheel spinning.
Worst case scenario, one bolt, one shift.
When a 550-tonne excavator calls in sick, maintenance supervisor Kenny Diamond and his team of experts must diagnose the problem.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry.
But a call to duty means there's no day off for this heavy lifter.
This has to go back in today and the machine has to be working at 6 o'clock tonight.
Elsewhere, a very different piece of mining equipment, an underground roof support, needs a lift. But there's a major hitch for mechanical fitter Sean Gunning. The lifting point is missing.
So we're just trying to decipher how we're going to lift this.
What would have been a simple lift just got a lot more challenging.
Try to find another point where we can lift it up.
And there's no time for gushing at Wivenhoe Dam. Maintenance on the radial gates requires a skilled team led by a highly experienced dam operator.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder.
It's all about pressure. A high-pressure water gun, that is. The world's largest coal export facility is at Port Waratah Coal Services in Newcastle, New South Wales. Every year, Port Waratah's terminals have the capacity to export 145 million tonnes of coal. The coal is transported by train from mines across the Hunter Valley region and loaded onto 1,200 vessels and shipped out to the world. This giant bucket wheel is critical in meeting export deadlines. Known as a reclaimer, it's capable of scooping up 9,300 tonnes of coal every hour, running 24/7, 365 days a year. Reclaimer number 411 has stopped turning for some major maintenance.
Today's task is to remove 411 bucket wheel gearbox. So he's driving the bucket wheel which picks up the coal and delivers it to the conveyor.
Having worked on building these machines himself, Darren Westwood, known around here as Booker, short for the Book of Knowledge, knows the importance of keeping this mega machinery in check and fully operational. Ahead of him is a huge job. Weighing in at 23 tonnes, the massive gearbox driving reclaimer number 411's 30-tonne bucket wheel requires replacing after almost 2 decades of operation. A new gearbox is transported 4,000 kilometres across the country to arrive at the Kooragang coal terminal for the replacement. The gearbox is attached to the bucket wheel drive shaft by 16 large bolts. Taking them out sounds like an easy task, except for one challenging technical issue.
Those coupling bolts have been serviced now for 18 years, and past experience has showed us when they're jammed, they take about 130 tonnes of removal. One bolt, one shift. So 16 days of just bolt removal before we could actually remove the gearbox.
Bolt removal is an extremely difficult task which will require a crew of 4 men working 12-hour shifts continuously around the clock. How long it will actually take to remove the gearbox is unknown, but being such a critical piece of machinery means deadlines are tight. So the less time this monster's in shutdown, the better.
We've been on this planning process for about 4 weeks. So correlating all the gear, getting the gear together, getting it tested, making sure it works, and then packing it up and delivering it to site.
Booker is the master of gearbox removals. He's already been involved in 2 of these heavyweight gearbox replacements on the other reclaimers on site. From previous experience, he knows there will be challenges. Once inserted into the gearbox, these indestructible bolts were never planned for removal. And after nearly 20 years in service, his worst nightmare is they won't come out at all. But the master has a backup for that scenario. Booker's plan B is in the form of 4th-year mechanical fitter apprentice Will Hammond.
From past experiences on other jobs, stud extraction being one of the most critical paths in order to get the gearbox off.
For his final year assessment project, Will designed this bolt removal tool, which has been cleverly called the Nutcracker. Yet to be tested on the job, the device will only be trialled if a bolt becomes stuck in the gearbox coupling.
It's got a 150-tonne hydraulic cylinder mounted inside it, and the idea of that is to force the remaining studs out.
With Will's hydraulic jack on standby and a new gearbox ready to go, Booker only hopes an agonising history with these bolts doesn't repeat itself. 750 kilometres north, across the Queensland border, near the regional township of Oakey, there's a massive machine flexing its hydraulic muscles at the New Ackland open cut coal mine. This 550-tonne excavator and its monstrous 30 cubic metre bucket should be working in the pit, chewing its way through rock and soil to get to the coal below. While it might look like it's fighting fit, the team are actually trying to get to the bottom of a serious mechanical issue. This morning, the only thing this excavator is doing is creating a massive challenge for the mine's maintenance supervisor, Kenny Diamond, diagnosing a problem in one of the 4 slew transmissions.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry, as it'll seize all the gears in the slew trans.
The job is to remove the slew transmission, also called a slew gearbox, and check the massive part for leaking hydraulic oil. A slew transmission is driven by hydraulic motors off the twin engines on the machine. When the operator moves the controls to slew or turn the body of the machine, the slew transmissions rotate to turn the excavator arm and bucket in a 360-degree swing. The pressure is on. The crew have only one 12-hour shift to have this mining machine back on track. To get the ball rolling, some forensics are happening in the belly of the beast, where oil samples are taken to try and determine exactly what type of oil or oils are leaking from where. Preparing the problematic slew gearbox for removal is Mark Van Dongen, a mechanical fitter with 20 years experience.
We're going to pick this motor up off the top of the transmission here. We're going to take it away with a Franna crane. Then we'll get that out of the way on the ground. We'll come back in, we'll undo all of our transmission bolts that hold the transmission in the frame. Then we'll hoist the transmission out.
But none of the big boys' toys will get fired up for these lifts until some smaller tools clear a pathway through these boom arch hoses to allow overhead access for the crane.
The boys are just going to spread the hydraulic hoses there, just use some come-alongs so we can spread them apart.
A come-along is a hand-operated winch used to separate the arched hydraulic hoses. While further down in the excavator, the hydraulic motor is ready to take flight on the boom of a crane. Despite the time pressure, safety is always on everyone's mind.
I don't want to get hurt. I want to go home to my family at the end of the shift. If there's pressure, it comes with the years on the job, but you've still got to make sure that you come out the other end of the job with all your digits and everything in place.
With the motor airborne and out of the way, the team's getting closer to their prime objective, the leaking gearbox. The sooner they can get to that, the better.
If we don't repair this leak and seal, the slew motor will actually run out of oil and seize up, and that'll be the end of the machine.
And that's not Kenny's only concern.
If the digger's not operational by 6 o'clock tonight, they're going to be behind on their overburden.
Having one less excavator working the pit, even for just one shift, means lower production, lower profits, and a pile of overburden that's got to be moved. Getting this done in such a short time frame is a major challenge, considering there's going to be a lot of mechanical detective work to figure out the cause of the leak. Stepping into the unknown, will this machine be ready for a call of duty on the night shift? 940 kilometres north of Oakey is the tropical city of Mackay, a region famous for sugar and mining. The Hastings Deering Asset Solutions Workshop has been charged with overhauling a hydraulic roof support from a longwall underground coal mine in central Queensland. For Sean Gunning, mechanical fitter acting as project lead this morning, the shift is off to an interesting start.
Well, last night, Boilermakers made a mistake, obviously, and cut the main lifting point off.
The crew need to raise this hulk to access a cylinder leg, but there's a problem.
There's supposed to be a lug exactly like that on this side, but in your main weld areas around here, they've obviously found cracking, and hence why they had to cut it off.
The Boilermakers on the night shift have cut off the main lifting point.
I don't think the Boilermakers would have known that we had to lift it.
Ironically, lifting is what these roof supports are all about. Powered down in a workshop, it's hard to take in context these transformer-like components. But hundreds of metres below the surface, this roof support is an integral part of an underground longwall mine. Projects and Overhaul Supervisor Warren Samuel, known around here as Wazza, sees hundreds of these units come through the workshop.
This is just one component out of a complete longwall package. This roof support is about 65 tonne.
Longwall mining is an underground coal mining technique using hydraulic-powered roof supports which are interconnected along the length of the longwall face. Massive shearers cut coal from a wall face, which falls onto a conveyor belt for removal. As the shearer advances along the wall, it exposes an area of the coal seam overhead that's retained by the roof support to maintain a safe working environment.
So these hydraulic roof supports support that by putting anywhere between 1,400 to 2,000 tonnes of pressure back into the roof to be able to hold that strata in position.
To put that in context, each of these roof supports is capable of holding the weight of 4 A330 aircraft. But before this unit can start to support that vast amount of weight, some problem solving needs to happen. With 5 years' experience on the job, Sean's using a solid alternative.
We've got some other lifting points just in there. We're just gonna throw some bigger shackles through, and we'll just have to change the lengths of the chain that we've shortened. And hopefully it should be all good. So we're just going to put this other shackle on, and then we'll have to move the crane back over that way and lower the chains down.
But jostling bulky machinery is never simple. Time to call in the big guns. Cue the overhead cranes.
A little bit too much for one single crane to do, just because when you go high it sort of picks up a little bit more than 60 tonne, the alarms will start going off because they're only 60 tonne cranes. So here's 2.
With 2 cranes in use, Sean uses a 100-tonne spreader beam to balance the weight. Heavy chains are readied to carry the 65-tonne load.
Because we've had to change the lifting points where we're lifting, we've just got to change the amount of links, how the crane's set up, just to get it to lift evenly.
It's a time-consuming process, adjusting then readjusting chains to get the balance right.
Very heavy. Finger biters, sure. Lots of pinch points.
An hour into the job, and another challenge presents itself for the crew to detangle.
The side seal has been taken off, so the pins that are sticking out, there's little grooves above them. And the chain's getting caught in as we're going up, so it's getting tight above the pin, but it's still loose down the bottom from the lifting point, and we needed to get tight.
With delays beyond their control, will the team find a solution to lift a roof support stuck firmly on the ground? 80 kilometres northwest of Brisbane, sitting steadfast on the stunning landscape of the Brisbane River, is the impressive Wivenhoe Dam. This earth and rock structure is 59 metres high and 2,300 metres long. The dam wall holds back the 1.16 million megalitre reservoir when at full capacity. The concrete spillway at Wivenhoe Dam has 5 radial gates, 12 metres wide and 16 metres high. They're among the largest of their type in the world. Each year, the radial gates undergo a crucial safety check of the hydraulic motors and winches, along with raising the gates for a visual inspection. Doug is a veteran dam operator and leading today's radial gate inspection. Having worked here for 22 years, he knows the dam well. During that time, he's witnessed extreme weather events which have relied on his skill as a dam operator.
Done many releases, but when we had a really big rain event.
The decision to build the dam came after the torrential rain from tropical cyclone Wanda flooded the Brisbane River, devastating the city of Brisbane and surrounding areas in January 1974. Today, Doug and his team, Matt operating the crane and apprentice Ash, are preparing to retrieve a 63-tonne bulkhead gate stored in a large underground concrete container. Radial gates are the most common type of spillway gate in use today. Water pressure is transferred from the curved face to the radial gate arms, which transfer the load to bearings on either side of the gate opening. A bulkhead gate is inserted vertically in the spillway to hold back the water, allowing the radial gates to open for maintenance. Matt is in charge of driving the enormous crane which straddles the dam wall. Using a remote control, he's able to position himself to monitor operation. The main purpose of the crane is to retrieve the bulkhead gate. It's a slow process moving the crane along the wall.
Well, the biggest challenge for Matt is, of course, lining him up and getting him to go inside the slot. Pretty restricted, the area for to go in.
The procedure relies on Matt's skill and experience to drop the locking hooks into the bulkhead. Slowly raising the bulkhead clear of the concrete container, the enormous size of the gate is revealed. Moving along the dam wall, tracks guide the crane into position. The bulkhead gate is designed to hold back the lake, so it's expertly engineered for weight reduction.
When you look at the gate, it's how it's fatter at the bottom. That's because there's more head pressure at the bottom, so it exerts more pressure. So as it's going up the gate, you'll see it's getting narrower and narrower.
During the maintenance period, a radial gate is inspected each day until all 5 are done. Today, it's Bay 2. The bulkhead is lined up with the bay using marking indicators to assist Matt to centre the position of the bulkhead in the spillway. Slowly, the bulkhead is lowered into the lake. Matt is constantly watching and adjusting the crane. Fine-tuning guides the bulkhead gate smoothly into the slots.
These little shiny ones here, they're the end rollers. They'll help if going down, so if it's not quite laying straight, the rollers will help it shimmy its way down. Ideally, they won't touch. These other big fellas, they actually take the loads.
With the bulkhead lowered safely into position upstream, water cannot enter through the spillway. The dam serves a dual purpose of water supply and flood mitigation. Operations and Dam Safety Engineer Michael Raymond supports the team that operate the dam during flood events.
The dam won't stop all floods, but it will actually certainly reduce a lot of flooding, and what it does that by slowing the floods down as it travels through the dam.
It's during extreme weather events when the ongoing maintenance operations performed by Doug and his team pay off, ensuring the radial gates holding back the lake are functional at all times. It's been a busy morning, but with a slow-moving crane and 64-ton bulkhead finally at the bottom of the lake, there's a sinking feeling this job's slipping behind schedule. At Port Waratah, leading tradesperson Darren Booker Westwood and his crew are gearing up for Reclaimer 411's gearbox removal. First up, they need to extract 16 large coupling bolts from the gearbox drive shaft, and with past experience of one bolt, one shift, Booker's hoping history won't repeat itself.
The roots of the crew behind us are so big because you've got to use packers and jacks and pressures, and there's a lot of communication with regards to pressure on, pressure off, release, just to remove the bolts.
Bolt removal is a high-risk operation, working with hydraulic pressure in a confined space environment and at height. These highly skilled mechanical fitters are harnessed onto the work platform. Risk assessments are in place and an emergency rescue plan is on standby. Safety is the name of the game for these guys.
Give it to it.
Working shoulder to shoulder, with all eyes on the bolt, it's a four-man job. The jack operator gives a verbal cue for the pump to start.
Right, mate, give it to it.
So that's a bolt that's been removed, and it's one of the first ones, and that's why you need so much force. Every time you do 16mm stroke on the jack, it then's got to be replaced with a packer, another 16mm, and we've got to do that over 110mm. The whole bolt length 300mm, so it takes a bit.
Gauging the amount of hydraulic pressure needed to remove the bolts is an indication of whether this job will be delivered on target.
Righto, mate, give it to it.
The crew are using a jack to move this bolt with a high-pressure hydraulic pump with the equivalent force of 50,000 pounds per square inch, or PSI.
Righto, nice and steady.
And it's not moving.
Suck him in.
Time to wind it up a notch to 60,000 PSI.
Righto, Shippy. Nice and steady.
Finally, movement. And the bolt comes free. After almost 24 hours of continuous labour, just 8 of the 16 bolts are removed from the gearbox. The only way to access the remaining coupling bolts is to manually rotate the 30-ton bucket wheel. It's a dangerous task, and everyone except for the winch crew are cleared from the job site. Communication between the crew is critical, as winches and chains are locked onto the buckets. Turning this Titan is a slow task. Finally revealing the remaining 8 coupling bolts. With the bucket wheel rotated and safely locked, Booker's bolt crew are keen to get back on the tools to get the old gearbox out.
Nice and steady. Righto, mate, give it to it. Righto, give it to it.
With patience, determination and focus, these masters at work have cracked the code to remove the bolts. But Booker's been here before, so he's not ready to acknowledge victory.
Don't count your chickens before they hatch, of course we've still got 6 to go.
The crew are so close. They're determined to complete the job on their shift so they can have bragging rights. It's 15 bolts down and 1 to go. Across 3 shifts, Booker's crew removed 16 bolts in 32 hours, a record time. Plans now move to installation of the new gearbox. But a changing weather forecast could mean their biggest dilemma is yet to come. Out on Queensland's Darling Downs, a 550-ton digger has been taken out of the pit at the New Ackland coal mine to get to the bottom of a mysterious leak in a slew transmission. An issue maintenance supervisor Kenny Diamond and his team need to solve before the night shift.
It's quite urgent we get the job done as it's leaking oil, and if it runs dry on oil, the gears will seize up and the machine won't be able to swing at all, so it'll be up for a new slew trans.
That's a costly venture that the guys are working hard to avoid.
As soon as we get that slew trans out, we'll know whether it's worse than just the seal.
With the 200-kilogram swing motor out of the way, the slew transmission is next in line for a morning flight on the crane. This hefty passenger weighs in at 2 tons. Mechanical fitter Mark Van Dongen stands by to guide it through the forest of hydraulic hoses that control the boom arm and bucket.
Trying to pull this out. Hopefully we find that the seal's damaged or not installed correctly, and we can rectify the problems.
Mark's keen to get the massive part on the ground and try to work out where the leak is coming from. He's hopeful, but there's a lot of unknowns. The crane makes light work of this solid piece of machinery, cautiously easing it down onto a pallet. After 2.5 hours of hard slog, the real dirty work can begin. With the grease cleared out, a rattle gun is used to remove the bolts and reveal the inner workings of this slippery character. Yet again, the crane's called into service. As the team probe the innards of the slew transmission for answers, the clock ticks closer and closer to the shift change. In tropical Mackay, the mercury is well past the 30 degrees Celsius mark in the Asset Solutions workshop. Overhauling this piece of mining equipment is proving almost as challenging as the job this hydraulic roof support undertakes hundreds of metres below the surface.
It's essentially an evolution of a block of timber that people used to use in coal mines. The hydraulic roof support has evolved into what we see now. Our nickname for that is a chock.
It's the perfect analogy for these massive mechanical wedges which sit between the floor of the coal seam and the roof of the longwall mine. Today's mission, supervised by Wazza Samuels, is to raise the unit to access a faulty hydraulic leg.
Through testing, we found that one of the leg cylinders, which holds the top of the roof support up, has got a leak in it, so we're replacing that out at the moment.
It sounds pretty standard, but not when the machinery weighs 65 tonnes and not when one of the main lifting points has been removed. Sean Gunning, the fitter on project lead this morning, has been working with Wazza and the crew to wrangle this metallic behemoth into position.
So it needs to be moved forward, it needs to be a stand under the bottom. So we just had to come up with another idea how to do it.
After 5 years on the job, Sean isn't phased.
Fair few jobs come through where you have about 50 to 60 of them, all in a really short turnaround.
But with this particular unit, nothing is happening quickly.
Generally what we will do is we'd do it a lot different to this. We'd have the crane set up, holding the canopy up. We'd take the leg out and there'd be a new one to go straight back in. But we don't have any cylinders on hand at the moment. So this one's going to get taken out, which is why we have to put the stand under it.
Progress is slow, but safety is always the top priority. And throughout the operation, Wazza is standing by, ready to give expert advice and hands-on assistance.
No, well, I came from the same place that these guys are now. I don't see why there's any reason why I can't give back if they need a hand. Yeah. I'm just concerned that we're going to put a lot of weight on this once we go to lift it all in one hit. So if we put it back down again, hook the hydraulics up to the front leg cylinders and just take it up so we can remove that.
I think we will be, if we were, we're just going to take the stand out and we will for you.
Yeah. What do you reckon, Sean?
After 2.5 hours, with stands and chocks in place, will Sean and his team be ready for liftoff? At Wivenhoe Dam, Doug and his crew have just settled the enormous bulkhead gate into place in the spillway to hold back the lake. Before they can open the radial gates, Doug has to remove the crane's connecting hooks from the bulkhead gate.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder, go down so we can disconnect the crane.
It's a risky trip down to water level and requires Doug to wear a harness to reduce the dangers of a fall from this height.
Come and do the other one. All clear, Matt. Up we go.
The radial gates have not opened to release water from Lake Wivenhoe since 2011. But when these massive gates open onto the spillway, it's an awesome spectacle. With the bulkhead gate sealing Bay 2, Doug prepares to take vital readings from the hydraulic winch motors, which raise the radial gate.
It's full operational swing. I'll give you a call every metre so you can obtain your readings. Ready when you are, you can start the pump.
As the gate begins to rise, water trapped between the bulkhead floods onto the spillway. It's enough water to fill a family-sized swimming pool. Paying careful attention, Doug checks the pressure gauges.
Every metre we just get our pressure readings. And the different sides you can see on the gauges here, we've got the different pressure gauges, the raised, lower and case pressures. So we just record those at every metre interval.
While Doug is doing his checks, he's coordinating with Matt, who's taking readings on gate positioning and pump pressures in the winch room.
Matt, 2 metres, 2 metres. We just have a good look around to make sure the brakes are coming off. These are the brake cylinders here. We've got a pressure relief valve here. We just monitor to make sure it's behaving like it's supposed to.
Doug checks the hydraulics for leaks and keeps an eye on the witness mark and bolt to ensure they're still lined up.
Matt, 8 metres, 8 metres.
With the stopwatch on hand, a record is made of how long the gate takes to fully open.
Just over half an hour.
It's important to check the gate safety mechanism.
Upper limits come on. That's what stopped the gate coming up. And we also check the hydraulic upper limit. There's an emergency upper limit that'll trip if this one doesn't work. Okay, Matt, if you want to shut that down, we'll just have a look at the, see what she looks like while it's up here.
That means this gate is going to get the full once-over. It's all about high pressure. A high-pressure gun, that is. Back at Port Waratah, preparations are underway to remove the gearbox from the boom arm on bucket wheel 411. A 130-tonne crane has been brought on site to lift the 23-tonne gearbox. It's a difficult lift. The weight of the gearbox means the boom arm of the crane will be at full capacity. Chains are attached to linking points on the gearbox, but because of its odd shape and position, each chain link must be meticulously fed out, one by one, to make sure the weight is evenly distributed and level on rising. After hours of preparation, the crane rigger gives the all clear to lift the gearbox. As chains take up the load, slowly the massive gearbox rises upward. Hanging from the outstretched boom, the gearbox is carefully manoeuvred into a shipping cradle beside its replacement. An operation that started 6 hours ago, rigging and lifting the mighty 23-tonne gearbox, is finally complete. But that's only half the job. The team is eager to lift the new gearbox early in the morning. But will a changing weather forecast wreak havoc on Booker's best-laid plans? At the New Ackland coal mine near Oakey in regional Queensland, a brains trust of mechanical experts are using their combined knowledge to try and nut out what's causing a leak in the slew transmission from this 550-tonne excavator.
We've only got a 12-hour shift to get the job done. The pressure's on to get it out as quick as we can in the next few hours, ascertain what the problem is, and then we'll make a decision from there and try and get the machine back on tower for the guys at 6 p.m. tonight.
Time is a constant pressure, and this machine needs to be up and running for the night shift. But the question still remains unanswered. What is causing the leak?
So we replaced these about 1,000 hours ago, and usually we get 24,000 hours, and the ones we've replaced are now losing oil.
More and more parts are removed and checked as the team dig deeper, working to solve this increasingly baffling puzzle. But until the oil samples come back from the laboratory, nothing is definitive.
We pulled this sleeve box out and we've disassembled it, inspecting everything thoroughly as we went. We can't find any evidence of anything being assembled wrong or anything out of place, so unfortunately it looks like it's okay.
It's an unusual situation where a positive is more of a negative.
I'm fairly disappointed that we didn't find anything. Yeah, would have loved to have seen something damaged. Would have been, if it was an obvious fix, would have been a lot better, yeah.
A huge effort with no real result, and time is not their friend today.
We're at the point now where we can't continue looking at it. We need to start putting it back together so we'll have it ready for night shift.
Carefully and precisely, the team reassembled this enormous workhorse in just a few hours. It's been a challenging shift all round, and even for this skilled team, it's a huge task ahead.
It'll be a fair effort by everybody here this afternoon, but I'm confident that we'll achieve our goal and get the thing going.
Although the team couldn't find an immediate fix, the excavator was back in service for night shift under close supervision. Several days later, oil tests assisted the mechanics to find the cause of the leak, replacing a pressure valve and solving the mystery. Mechanical workshops are challenging environments at the best of times. One crew in the workshop have been battling with this monster, an underground roof support for a large chunk of the morning. After 2.5 hours of trial and error to get this piece of coal mining machinery safely supported and chained up for a double overhead crane lift, it's crunch time.
It was something this big. 65 tonne is not something that you really want to take shortcuts on. We probably go to the nth degree when we're working on the big gear, but it's the same philosophy that we want to take into the smaller gear we work on as well.
Finally, the chains take up the slack, and there's air between the shed floor and this bulky machine. A slight movement in the chains, and the roof support jumps. But the experienced team are not phased. There's a support stand in place for this exact reason. It's a painstakingly slow process, gradually moving the machine up and then forward. Amazing to see this massive piece of machinery seemingly defy gravity. But not for long.
Nice one. Okay, so we'll take the chains off. Reposition the barricade.
With the roof support secured and in a safe work area, the real work can start for Sean and the maintenance crew, removing a faulty leg cylinder.
You can get coal, you can get anything in there, and the tiniest little speck of dirt can get inside and wreck the whole seal, which will cause it to bypass it. It won't hold any weight, so the roof support will just start lowering. If that happens, it can just collapse, and if you've got workers under there, it's not a real safe thing.
The guys that work down there do audits across the system, so they pick that up pretty quickly and change it out underground, pretty quick smart. So while it's in here in the workshop, we'll take advantage of the fact that we can do it in a workshop environment with an overhead crane.
3.5 hours after the discovery of the removed lifting lug, Sean attaches hydraulic lines to raise the roof support. It's been a massive effort to get to this stage. And finally, the guys get a good look at the rear cylinder. But just like the Mackay Heat, the work's relentless. Their next mission, to remove this 3-ton leg. Every year at Wivenhoe Dam, the 5 radial gates are inspected and cleaned. Today the team have been assigned maintenance of gate number 2. Matt doesn't mind working under pressure to remove the thick algae. Checking the radial gate with apprentice Ash, Doug examines the submerged surface from an inspection platform inside Bay 2.
We got no dramas. Not we found yet anyway. And that's pretty typical.
To protect the metal surface from rust corrosion, the submerged section of gate is painted with a hard-wearing epoxy paint. Previous spot damage is also examined to ensure the integrity of the repair.
This is the patch that we did previously. Now this is a 2-coat epoxy system, high-build epoxy. The first coat's a little bit smaller and the next one's a little bit bigger, so it overcoats. So the next one would come a bit bigger like this.
After many years on the job, Doug compares the condition of the gate from his previous inspection. Satisfied it's in good condition, he gives the go-ahead to lower the gate.
All right, here we go.
Checking the winches, Doug has a stopwatch on the lowering gate. It's important to know how long it will take to close completely.
23.35 and 30 going up. Got a bit of 104 tonne assisting it going down.
With the inspection and cleaning complete and the gate secured, the job is done. With a structure as important as Wivenhoe Dam, inspections are crucial and equipment failure just cannot happen.
It's a rewarding job. We maintain the gear and watch it operate.
The ongoing maintenance provided by Doug and his team ensures the radial gates at Wivenhoe Dam will be fully functional at all times. In Mackay, a team of fitters are slowly making progress fixing a leg cylinder as part of an entire overhaul of underground mining roof supports. A big part of this job is problem solving, something fitter Sean Gunning and his crew have put to the test multiple times today with the challenges of lifting this 65-tonne giant. It takes teamwork and combined skills to work through these problems.
We've got a lot of great boys and a lot of experience here. As soon as I started, I could just see how well everyone was gelled together and just one big unit basically. Everyone seems to be mates outside of work as well.
After a day of stops and starts, finally the supports are in place and the team can get down to the job they had planned today. A chain block is used to support the 3-tonne leg to ease it out.
The time that it takes to do that preparations mean that we can do the job in a safe manner. The most important thing is get home at the end of the day. Spend time with your family and do the things that you enjoy doing.
5.5 hours have ticked by. And success, finally. The leg cylinder is free. Sean's a happy man.
Glad it's over. You get that on big jobs, but you gotta take what you get and roll with the punches, as they say.
Now that the guys have got the cylinder out, we're going to send that away to our overhaul facility. It'll be pulled apart, put back together again, so they can go back into another roof support. This roof support itself has got another leg cylinder that's ready to go back into it. So tonight, night shift will throw that in, we'll put it back up and begin the rehosing of the roof support.
After several false starts and lengthy delays, the team have pulled together to get the job done. When the rear leg is replaced, this roof support will go back into service at a central Queensland underground coal mine. At Port Waratah, Booker is at the mercy of the weather. His plans to lift Reclaimer 411's new gearbox grind to a halt.
The rain has come in. The forecast is scheduled for about 40 millimetres of rain. So that's come in and impacted the schedule.
The work site is a total washout.
The main priority when it rains is that we can't allow people up on steelwork, the slipperiness. It's utmost important that safety is our first priority.
Water, man and machine is a lethal combination, making a 23-tonne gearbox lift highly hazardous. And this downpour has dampened any hope of activity on site. Ongoing delays to the maintenance schedule will have a serious impact on operations.
We've got to reschedule shifts and reschedule coal piles and a whole host of things happens.
As the window of opportunity to stay on time and on track slowly closes, Booker needs to look for other options.
The lift that we're going to do today will be cancelled if any sign of high winds because they've got to have control. So it might end up being the night shift will be the best place to do this work today.
Any type of critical lift after dark presents a whole new set of challenges. But right now, the rain is unrelenting. And it's Booker's job to assess the risks and make the call.
Due to the weather conditions, we're going to cancel today's crew and restart the night shift tonight.
As the day shift mechanics head home, it's a huge blow to operations. Right now, the installation of Reclaimer 411's new gearbox is officially off limits. Losing a 12-hour work shift means the night crew clock on for one hell of a battle to get 411 back on track. Mechanical fitter Mark Doll is called in to lead the charge, and there's only one thing on his mind.
100% about safety, making sure everything's all right and ready to go.
Preparing for a moment of reprieve. When it comes, it'll be all hands on deck.
So the torrential rain stopped. It's still a bit windy and we've got scattered showers, and when the opportunity comes, they're setting the lift up now. They've got it slung on the crane. They're going to swing it in.
Mark gets his moment. The rain is predicted to ease off, and he gives the team approval to go.
Heaps of eyes on the job, just seeing where the clearances and that are.
Make no mistake, wet surfaces, night lighting, shadows, and the smallest change in weather conditions, and this lift could quickly become disastrous. From lift up to swing in and descend, the crew's looking to get this done while the rain holds.
The way that the load's rigged up is very important so that we're not having to put it back down on the ground and re-rig it again. So the rigging has to be absolutely spot on.
A 23-ton critical lift is a white-knuckle ride. If the new coupling bolts are to withstand a lifetime in the field, realignment is one of the most critical aspects of this entire operation.
We can roll the gearbox, rotate it manually just by spinning the disc. The bolts have only got 0.1 of a millimetre clearance on them. You want to be plenty space at that side?
And it's in.
The gearbox is in position. They've torqued up 4 bolts to retain the weight of the gearbox. It's sitting on the pedestal at the back. The crane's removed.
All that's left are the new bolts. And just to finish off a mechanical fitter's dream, the clearance fit design glides them in with ease.
We'll put 16 on and these blokes will have the bolts torqued up by the morning.
8 hours later, Mark and his team of mega mechanics have done it. It's a spectacularly successful handover to Booker the next day.
The job is now complete, that's why it's nice and quiet. It's finally installed. Just checking the Denso tape on the bolts for corrosion protection.
And to keep the gears lubricated, it's time to fill up the oil.
When it comes to side, it's dry, so we fill them up to the mark. About 680 litres these gearboxes hold.
Will's plan B, the Nutcracker, is shelved for another day. But the hands-on knowledge gained by this final year apprentice is more than enough reward.
Yeah, I've been on the job since the very beginning in the planning stage and seen it progress all the way through to the commissioning, which is quite a rare opportunity, but it's been a really good learning experience for me.
As for Booker, the job's not over until this machine is fully operational. With the gearbox job complete, a full test run is on hold until other maintenance work on the reclaimer is finished.
From our point of view, we just wait the completion of the cable reel work and we can move on. It looks like it's a pretty good job.
Keen to power up this mechanical beast, Booker's on the home stretch. And when Reclaimer 411 is fully geared up, it will be ready to churn through mountains of coal for years to come.